How to solve oscillation questions. Since there are quite a large range of oscillation questions, and I can't cover every single kind, I'm going to start with some general tips that you can apply to any question. Firstly, when a question refers to the defining equation for simple harmonic motion, it means A equals omega squared x, negative omega squared x. Before doing anything, set your calculator to radians. Degrees will give you incorrect results, but make sure to set it back to degrees after you've done that, since the majority of equations in physics use degrees and not radians. Approach the question like a SUVAT equation. Note down which bits of information you've been given and what you're trying to find. Before doing any calculation, construct an equation algebraically so you can solve the whole thing in one step. Only once you're ready to use it should you input numbers. Now, to give you an example question, a mass is hanging from a vertical spring pulled down. It is then released from rest at time 0. The mass oscillates vertically in a vacuum, so there's no damping, with simple harmonic motion about the equilibrium position. The string is in tension at all times. At time t.5 seconds, the magnitude of the acceleration a of the mass is 3.6 meters per second squared, and displacement of x is 4.6 times 10 to the negative 2 meters. Use the defining equation for simple harmonic motion to show that the natural frequency f0 of the mass spring system is about 1.4 Hz. The defining equation only uses omega, acceleration and displacement. This means that we do not need time. Angular velocity, which is omega, can be turned to time period or frequency and vice versa without having to know anything else about the question. So we can now construct an equation using the defining equation. As we know, omega is equal to 2 pi f, so we substitute that kind of the equation, that kind of omega, into the defining equation for 4 pi squared f squared x equals acceleration. We can then rearrange the equation so that f squared is on its own, and then root both sides so that f is simply equal to f. Only then should we put in our numbers. This helps improve accuracy, and even the smallest change in numbers can lead to vastly different answers across simple harmonic motion questions. So it's very important that you're incredibly accurate and put in the exact right numbers, or at the very least write down exactly what numbers you use so you can get marks where the examiner can see where you've messed up. Now we are given the same situation, but are instead asked to calculate the amplitude of the oscillations. This would lead us to use a different equation. There are 3 different equations of simple harmonic motion that include amplitude. Of the 3, only one is going to be useful to us. The first one, v equals plus minus omega to the root of a squared minus x squared, isn't useful because we don't have velocity. The second, x equals a sine omega time, you only use that equation when the oscillator starts from the equilibrium point. In this question, it specifically says that the mass is pulled down off equilibrium. If there is any kind of energy present in the system before the mass starts to move, that means that you start with cos. And this equation is useful as in this case, the oscillator is pulled down, so it doesn't start from equilibrium. And in order to use that equation, we would put x equals a cos wt in. We'd then rearrange so that a is on its own, so it's x over cos wt. And as before, omega equals 2 pi f. Since we already know f, it's easier to use that to get the value of omega rather than just using time period. And once we put all those numbers in, we get 0.0796 meters. The exact answer you get can massively change on the numbers you use. For this question in particular, there was a list of vastly different numbers, and the numbers which you would put in as your value for f, and how that would alter the answer you got. You will be rewarded no matter which of those numbers you were to use. However, it is worth writing down which numbers you have used so that the examiner knows that you haven't made a mistake or you haven't answered incorrectly. You have just put in a particular number and that has given you the particular answer.